Hi grade 11s. Okay, today what we're learning about is general solution, and I know that some of the textbooks and some teachers teach it to you guys with different types, and that is perfectly okay. I'm just going to show you a way that I find much more easier to understand, and if you're anything like me, you like seeing where this comes from before you can fully grasp what the concept is about. So what I like to do is either one of these two things. I want to get it where it's a ratio angle equals number, like I have over here, sine 2 theta equals 4. See, sine is my ratio, angle equals number. Or else, okay, here's another example, ratio, angle, this whole thing here is my angle equals number. Or else, what we want to do is get it where it's a ratio angle equals the exact same ratio angle. So like I have over here, sine theta 30 plus theta, that's my angle, equals, see, the exact same ratio, and then that's the angle over there. All right, I made it look super complicated just so you understand what we're aiming for. Okay, now let me first, before I start with everything that I have over here, let me first show you what we are getting to. Let's do this. So we're going to borrow from your knowledge of trig functions. Right, let's draw a simple sine graph. Alright, horrible looking sine graph, but anyway, here's what we're doing, okay? If you had to solve a linear equation, you would agree that you're going to get one solution. If you're going to solve a quadratic equation, for example, you're going to get two solutions. If you're solving a cubic equation, you're going to have three solutions, right? Etc, 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 and that holds true. Now when we solve in trig equations, right, do you notice and do you remember from your knowledge of your trig functions that the sine graph has, I'm starting with the sine graph, so the sine graph has a period of 360 degrees, and what this means is that every 360 degrees it's going to repeat itself, right? So if I had to ask you, so this is our equation, so far y is equal to sine x, that's what our graph looks like, right? So if I had to ask you, where is y going to be half, for example, so I'm asking where is this happening. Let's see, let's say this here we know is 1, this here at the bottom we know is -1. I know my graph looks horrible, but stay with me, right? This here is half. So you agree with me that my solution is somewhere here, somewhere there. It's repeating itself again, somewhere there, somewhere there. It's repeating itself there and there. I'm basically asking for all the solutions where it's equal to half. So it's all of those solutions. And it's not only on the positive side, it's going and extending onto the side, onto the negative side. So the side, let's say this continues there. It's asking for all those possible solutions. Now remember when I just started, I said this is called general solution. So what we're doing with this is we're solving trig equations, but because of this trig graph, okay, and because there being not just one solution, there's millions and billions of solutions for this, we are generalizing that solution. That's what we're doing, okay? Now, how on earth would we be generalizing that solution? Forget the rules that I'm going to show you. Let's understand this. This solution, let's call this point A, okay? Do you agree with me? To get from point A to this next point over here, I would have to add exactly 360 degrees. And to get from this point over here to the next one over here, I'd have to add again another 360 degrees. And another 360, another 360, another 360 degrees each time. Therefore, getting me with my solution, therefore getting my general solution to be everything that our answer was over here plus 360 degrees, right? If I wanted to get from this solution, let's call this one over here B, to the next one, again, I'm adding 360 degrees, 360 degrees, 360 degrees, and that would work. So basically what I did for the first one, from A to each one, would hold true for this one over here. I'm adding each time 360 degrees. Let's write this down, and B was plus 360 degrees. Okay, Let's see if it would have worked in the opposite direction. If I wanted to get from A to the next one, you would agree with me we're subtracting 360 degrees from it. And to get to the next one, minus 360, minus 360, minus 360 each time. So that means basically I'm adding or subtracting 360 degrees each time. And the same thing for my B. I'm adding or subtracting 360 degrees each time. Now, how would I generalize this? This is where you're going to see something. K is an element of integers, and you're going to see this plus K times 360 plus K times 360. So this is me explaining that part to you. K is an element of integers. What does that mean? It means that K is one of the numbers that we classify as integers. Remember, all of our integers are our negative and positive counting numbers, right? Like -1, -2, -3, or else +5, +6, +7. That's what it is. So what we're doing over here is by saying plus, I'm going to take away the minus because we already said it's an element of integers. So that means that this K is both positive and negative. So let's take that part away, right? I am saying that no matter what number I substitute into this place of K over here, as long as it's an integer, I'm going to get all my possible solutions for this general solution equation. Not general solution equation, I mean trig equation. That's what I'm saying over here, right? So let's write this down for you guys. For sine, and I've written it down there, we know we need to figure out what our answer is, plus K times 360 degrees, right? And we noticed that there wasn't one but two answers. So there's two answers, plus K times 360 degrees. How do I figure out, or how do I differentiate between this first answer and the second answer over here? Let's go back to our graph. Let's quickly split this up over here. This here is 90 degrees. This here would have been at 180 degrees. This would have been at 270 degrees. And 360 degrees, and those numbers look oddly familiar to us. We know that between 0, this is 0, 0 to 90, this is quadrant 1, 90 to 180, quadrant 2, 180 to 270, quadrant 3, 270 to 360 is quadrant 4. Do you notice how our first solution for this alphabet A that I represented is in quadrant 1? Okay, remember this. So that means our first solution over here is in quadrant 1 for A, okay? And then the second solution to get from this one to this one would be in quadrant 2. Okay, so let's remember that. The solution here is in quadrant 2. Okay, interesting. Right, and then let's move on for our cos. Oh, hold on one second. I just realized something. What happens if I asked you for y is equal to -half? Okay, so that means, let's say I asked you here at the bottom, you agree with me that my solution would be over here and my solution would be over there, right? So in this particular case, do you agree with me that my solution for negative, anything that's negative, is going to be in the third quadrant and fourth quadrant, and then repeated 360 degrees later, 360 degrees later, 360 degrees later, 360 degrees later, etc., etc. So let's summarize this part. This was for anything that was positive. If it was negative, you don't have to be writing any of this down. I'll mention to you guys what needs to be written down in your books. Okay, for still agree with me that it's still plus K times 360 because we're moving each time by 360 degrees. The only thing now is if it's negative, if our number is negative, we're going to end up in the third and fourth quadrant. Don't forget this. This is very important. Let's go to our cos graph, right? I'm busy scribbling here for you guys, but stay with me. So, cos graph. Let's just extend that way. Okay, I didn't draw so much of it, but the same concept is going to apply. If I asked you for a particular point, same like I did over there with half, let's say I'm finding my solutions, right, for half. There, and then the next one is again 360 degrees later, etc., 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 right? You also remember from your knowledge of trig graphs that a cos graph's period is also 360 degrees, meaning that from one start of the cycle till it completes that cycle, it takes 360 degrees. Remember that. So same concept is applying over here. The reason why I drew out this cos graph for you is 1, 2, 3, 4. If I'm asking for a positive solution, I want you to notice that it's in quadrant 1 and in quadrant 4. If I had to ask you for, like this one over here, a negative solution at the bottom over here, negative solution would be in the quadrant 2 and quadrant 3, and that matches up very perfectly to this over here. For cos, it's positive in the first quadrant, positive in the fourth quadrant. That is exactly what we've seen over here. Positive in first, positive in fourth. Okay, let's write this down. So positive in first, positive in fourth, negative in second, negative in third. It's all going to make so much of sense in a bit, okay? I forgot the k. K times 360. K times 360. K times 360. Everyone, up until now, you should understand why we are doing this, why we say in the plus 360, and why we are determining which quadrants it goes into. Okay, let's talk about our tan graph. Let's draw that quickly. With the tan graph, you would notice that it completes its cycle in 180 degrees. Okay, can you see there? To there, it's completed. Okay, you also know that it has asymptotes. Very important to remember that. Okay, 0, 90, somewhere there is our 180, 270, 360. Okay, remember I said that it completes its period in 180 degrees. Okay, same concept like I did over there. If I ask you for a solution anywhere, let's say I asked you for 5, for example, 5 is somewhere there. I'm going to draw that dotted line and it's going to touch the first solution is there. Second one is there, third one is there, etc, etc, etc. It continues and continues forever. How do I get from the first one to the next one? You add in this time 180 degrees rather than 360 degrees. Why is that so? Because of the period being 180 degrees. Okay, why did I draw this graph again for you? So you can see if we have, this is quadrant 1, 2, 3, 4. If we have a positive solution, it's here in quadrant 1 and in quadrant 3. If I had to have a negative solution, it would be here in quadrant 2 and in quadrant 4. And you can also notice that the exact same no, ignore that for a bit. I'm coming to that in a bit. First quadrant and third quadrant for positive numbers, second and fourth for negative numbers. First and third, second and fourth. Positive, negative. Right, so that's what we summarized from our trig graphs. But how on earth is this helping us? How are they going to ask us questions and say we have to find the general solution? Right, that's what I'm about to show you. So everyone remembers this over here. You should know this Gauss diagram and you should know how it links to all of the graphs, right? You should also know, all your trig reductions, but these are particularly important. The 90 minus, that's why I wrote it down here for you. You should know, I discussed this, why it's plus k times 360 for the sine and plus k times 360 for the cos. Why it's plus k times 180 degrees for the tan. And then you should always mention down k is an element of integers, but I'm going to show you that in a bit. Okay, I wrote here that for 10, if it's positive, we only have to consider the first quadrant, and if it's negative, we only have to consider the second quadrant. And you can actually calculate that if you want, and that's what I said. I'm coming back to that in a second, right? What's happening over here, because of the 180 degrees, the solution is basically repeating itself exactly the same way in the third quadrant. Remember, our diagram, our class diagram that we work with is the full 360 degrees. And in that 360 degrees, if you're using a 10 ratio, you're going to have the exact same solution repeated twice, quadrant 1, quadrant 3. Okay, and the exact same solution if it was negative repeated in second quadrant and fourth quadrant. It's exact same thing. So because we're lazy and we're mathematicians, you don't have to write it out twice. Would you get it wrong if you wrote it out twice? No, absolutely not. If you wrote out both the solutions, okay, for positive and both the solutions for negative, like how you would do for sine and cos, that is perfectly acceptable. If you want to, you can just write out for positive first quadrant, negative second quadrant. Okay, it's going to make a whole lot more sense in a bit. I'm just showing you all the things that you need to understand before. Okay, other things that you need to remember, your two identities that I taught you, sine squared theta plus cos squared theta equals 1. Don't forget, you can interchange this, okay, like how we've been doing with our identities. And don't forget that sine theta over cos theta equals tan theta. Now I represent it with theta, but remember this, as long as this angle and this angle are exactly the same, it's this over here. Don't forget that. Let us start. Actually, I'm going to make this into a separate video with the actual general solution. Let's keep this one as an introduction.